Hi and welcome. This time around is another lens project. I'm going to be adapting this lens to work with an Arri camera, and it's going to be multiple adapters to adapters. So this is the back of the lens mount as it stands. This is an adapter that I am going to be building a new piece for. So this guy right now, this flange would meet with a different kind of camera mount, and I'm not sure which because I'm not an expert in this sort of thing, film cameras particularly. And we're going to make a new piece. We're going to unscrew this guy off of here, and we're going to make a new piece that meets up with the larger of these two guys here. These are both adapter plates that will fit on, I believe, an Arri current high-def camera. I think high-def. I don't think it's film. So they have set screws along the side. So basically what we will be making is a new flanged piece with a cylinder sticking out that will slide in and out of this one. And the point of sliding in and out is so you can set back focus on the lens, because this lens was set with a fixed back focus for the camera it was designed for, but it doesn't match this one. So you need the adjustability. And so there are 4 set screws to lock it down. So you use a pinwheel chart and you zoom all the way in, find focus, pull wide, and then adjust your back focus until you get, which is this length, this distance here, until you get the lens focused, and that way the focus will track. So that's the project. It's a pretty straightforward one. My concerns with this one is this flange here is 40 thousandths thick that I'll be reproducing, and I need the bolt hole spacing on this guy. 40 thousandths is not a lot of material. So the lens will be supported with lens bars, so it won't be hanging off of this adapter I'm making. One of the things I need off this lens adapter is the bolt hole spacing for this flange, and these screws are stainless, so I normally would put them in a magnetic dish, but that's not working here. So I got to pop these guys off, and I've got to try and estimate the bolt hole spacing for this flange, which pops out. It's a really nice fit, and because of the lens adapter pieces sticking out the front, I am going to actually have to flip it over and try and figure it out from the back. So I've got these conical point tip adapters that I covered in one of my quick tool reviews. When they're all the way closed, they're 0.375, and they let you measure things like this reasonably accurately. So you just got to make sure the cones are seated well, and it looks like 2.344. Let's see if I switch. I'm going to guess 60 millimeters. Let's see what 60, would it reach 60? I don't know, 59.5. That's weird. You would think these being metric, most likely, they would have chosen a whole value, but I'm thinking 59.5 millimeters for these guys. Let's see. Okay, I think that's what it is, which translates to 2.342. So that's what we will do. To find the hole diameters, I used a set of pin gauges, and this one is 0.101. 0.102 just catches. Actually, this one catches in some of the holes, so it's right around here. Finding diameters of holes like this reasonably accurate. Pin gauge set is a great way to do it, and relatively inexpensive, so recommend it, getting a set. So if we probably go 0.1, we'll probably be pretty close. They're countersunk as well for those small screws to fit in, and gotta make sure not to lose those. Those would be hard to replace. And we'll just proceed from here. All right, I got a piece of rough dimension stock here. Got it in my 4-jaw chuck, and we're gonna build the part out of this protruding portion. This is 304 18/8 stainless. First step is going to be take the overall stock down to the largest diameter, which is the outside diameter, which is 2.54. We're going to take 50 thousandths depth of cut, and we're going to go the full length. This is 5 thousandths of revolution feed rate at 440 RPM. The tip of this insert's been a little bit jammed up. It's not in a great shape. So I'm going to use it to rough with, and then I'll flip it around. The stainless is really gummy, and it actually welds itself without lube into the insert, which leaves a really nasty finish here. But also the insert is a bit damaged, so like I said, when I do the final pass, although it mostly seems welded metal. So let's see what a difference it makes if I add a little bit of lube to the cut. And a significant improvement in finish. So you're always wondering whether or not lube works, and I've always on the fence about it, especially since the cutter going this direction is going to be curling the metal up this way. So if the lube is on this side, how much lube gets around, and apparently a little bit, to get to the cutter, because a significantly different finish, surface finish from the last one. Here's the surface finish close up, using lube the whole way. It looks like there's a tiny bit of chatter. You can't feel it. It's not a perfectly smooth surface, but could take some sandpaper to this and clean this up. That's just using copious amounts of lube. Very big difference from not. When you don't, what seems to happen is the cutter gets some stainless welded to the tip, and then that starts to pull off material in clumps, and it leaves little bumps all over the surface. So lube is kind of key with 304 apparently. All right, so the back of this here has a 40 thousandths thick section that needs to fit in here, and that part needs to mate up with this little relieved section here, and you can see good nice fit, so that'll be perfect. Now we got to reduce the inside. Here's some interesting thoughts. So this is the flange I'm making a replacement for, and it will have a 40 millimeter extension tube that will slide into this one and allow the back focus to be adjusted as such, and tighten these set screws here to lock it in place. The lens itself will be supported by bars, as I mentioned earlier. Now I was thinking to myself, the screws that came out of this are really small, so I wanted to make this 40,000, the new one 40 thousandths like this one is, but I'm realizing there's no real need to. I can always countersink these holes to let the screws still fit while not giving up some added strength by making it 100 thousandths thick, which I think I'm going to do, because there's a lot of weight there, and I think it'd be advantageous to make this bottom flange here a little bit thicker than 40 thousandths. So I think we're going to do that. Change of plans. Often I do this in the middle of a project if I think of a better way. So now we're going to reduce 40 millimeters of this to this diameter right here, which is approximately 1.85, and we'll use this to test fit. We want it to be a nice, good fit. So I've changed the inserts to a square one so I can get a nice flat wall at the end. And I got a lot of material to remove. I got 3/4 of an inch almost to remove out of the diameter. So I'm going to take a 40 thousandths thick depth pass, but I've upped the feed rate to 9 thousandths of revolution. 50 thousandths depth of cut, 11 thousandths of revolution. It's breaking chips now, better than the stringy crap I was getting before, although they are flying absolutely everywhere. Okay, this should be really close. Shooting for 1.850, 2/10 under, which should be good. There we go. All right, so now I got to do the inside, and that one is not a critical size, but we are going to end up with a wall that's 1/10 of an inch thick, so it might get tricky. One thing first I got to do the final depth over here. I got to fix that, and so that's one more cut in this way, and then we will drill and bore out the center to approximately 1.550. That's actually not a critical dimension by any stretch. It just needs to clear the light path, and that's significantly bigger than the light path by about 1/2 inch, so we should be plenty good. I just want to make the wall thickness enough that it's sturdy. All right, should be right on the money. Beautiful surface finish. We're going to drill as much material out of the center as possible so that I don't need to bore it out, but I'm going to walk it up slowly because the wall is going to end up being pretty thin. So I'm going to start with a center drill just to help us get a straight, mostly straight start. Just going to drill. It's about 1.8 inches deep, so, whoops. I think we're gonna have to use some lube. The chips are welded on the drill bit, or slow it down. That might be a better solution. We'll just slow it way, way down. Because, yeah, chip welding, which causes it not to cut right. Use some coolant as long as we're at it. Holy moly. Okay, this is going to be challenging. Well, this is turning out to be a nightmare trying to drill this stainless. I had to go really slow. Broke several drill bits. I don't know, now we're up to 1/2 inch drill bit here. I need a hole big enough that I can get a boring bar through it. Problem is we have to go a couple inches deep. I think I need something like a gun drill or something, because I got to tell you, this is freaking tough. Or I need something that puts cutting fluid right at the tip, because this just keeps jamming up. I also had to switch to this Jacobs key chuck, a regular chuck, because the keyless chuck would not hold a tight enough grip at all on the drill bits. So I'm going to keep pecking at this here until I get at least 1.5 inches deep, and then we'll start boring. All right, we got about 1.8 inches deep. I am going to risk trying to go into a larger drill bit, a Morse taper based one, because they hold really well. Look at that, chip welding, chips don't even pop off. And that's using lots of lube the whole time. Anyways, we're gonna try a larger bit just to speed this process up, because I've got to open it up to about 1.550. So we do not want to have to bore all of that out, but we will if we need to. Once we got the initial hole, it's going better. The chips are still really gummy, but we are making pretty decent forward progress. This is a 3/4 inch. Okay. Next we'll hop up to 1 inch. Actually just slightly under. I'm taking 40 thousandths depth of cut here, and that might be a bit much for this small boring bar. Larger boring bar, a little over 1 inch boring bar, and so now we've got a little bit of oscillation on the outside of the part here. I have this tube micrometer, and you can see that there is a hemispherical end on one side, and that lets you measure wall thickness reasonably well for medium diameter parts. and I'm at 0.165, so we're going to take some smaller bites here, like 25 thousandths. So we have gotten this down to final dimension here, and there you are, almost 100 thousandths on the mark, even though it doesn't really matter. All right, next up we got to part this guy off. So I've set my DRO 0 by just catching the edge of the parting tool, and we're going to go back 1.615. Almost screwed that up, and we're just going to part this guy off. That should leave a flange of about 100 thousandths thickness, and we may have to clean that up a little bit. Well, unlike everything else that was so terrible, parting is working really well here. I'm just going to clean up the edge of this right now. There we go, pretty nice. Actually, pretty decent surface finish, a little bit of burr we got to clean up. Alrighty, so we have the part clamped down in the mini pallet, and if you don't have a mini pallet, another solution would be to super glue this to a piece of aluminum. I decided I have to come from the top because I need to countersink the screw heads. So it would have been easier if I'd left it on the main piece of stock and then parted it off later, but since I haven't, this is a solution, the mini pallet. I've got 2 pins it's pushed up against, 3 clamps. I'm only drilling, this isn't a big deal, so I think I've over constrained it, but we're gonna go for it anyways. I've got my X and Y 0 here, and we got less than half a thousandth out of center. So we are good there. Next up, I got to see if I can get a small drill bit down to where I need to go. I don't know if it's going to fit. I might have to make an extension shank for the drill bit in order to get there, or bits plural, because we want a flat bottom. So since there are only 4 holes in there at equal space, that basically puts them on the quadrant lines, so I don't need to use the bolt hole setting on my DRO. I just go plus or minus the radius in this direction, plus or minus the radius in this direction. I got all 4 holes. It looks like my drill bits are going to reach if they don't break, because this stainless steel has been really challenging to work with. I'm going to peck a lot and use lube. To prevent drill bit wandering, we're using a center drill first that's on an extension. Then we can switch over to the actual drill bit. And that's 2. All right, so here's the project done, and I had some spare M2 screws that I put in. The originals, tiny ones, are in here with the original plate, and it's all made out of stainless. One thing I did learn, hard lesson, almost screwed me, was that with a long drill bit, especially a small one, they will wander, and you've got to use a center drill. And for small things like that, where you're reaching deep, you either get a really long one, or you get an extension, or you build an extension for a center drill and use that, which I did, and that made the other 3 of the 4 holes dead on. One was really close, but it annoyed me that it wasn't perfect. That matches with this adapter plate, and the lens is sticking out here and goes in and out. The camera body is over here, and you adjust these 4 set screws to set the lens position exactly. And we're done. Thanks for watching. Hope you find it useful. Hope to see you next time.